2.1, vectors in the plane.
Roger.
Yeah. So two-dimensional vectors is what we're going to deal with. Two-dimensional meaning that we can talk about them on like the XY plane.
Yes, because could you have three-dimensional?
We could. We could talk about vectors in a three-dimensional space, and it makes it a little bit more complicated, but actually
a slight skosh, but not horribly so.
Not a ton more, but we'll be focusing on two dimensions because it's easier.
Right.
You know, that kind of thing.
Right. And it's what we're studying.
Yeah.
Two-dimensional stuff.
Okay, so whenever we have a vector, we denote it in, here we go, component form as A comma B. Notice we've got these like arrow brackets.
They're pointy, and let me tell you, on anything you turn into us, it's a vector, it needs to be pointy.
Yeah, no parentheses.
Yeah, that's a point. That's a point.
Okay, but a vector is something that has magnitude and direction, and it needs to have these...
Magnitude and direction.
Yeah. So the numbers A and B are the components of the vector, and in fact, the first one is the x component, and the second one is the y component. Because even though it's not a point, whenever we write it,
it's guides where the vector goes.
Right.
So we still have to have that information.
Right. So the standard representation of the vector AB is the arrow from the origin to the point AB. The magnitude of V is the length of the arrow. And the direction of V is the direction in which the arrow is pointing.
Right.
The vector 0, which this is bold. Anytime you see something bold, they're talking about a vector. And so if we were writing it, because it's hard for us to necessarily make sure that something looks bold, like the 0, the other way to write it is to put this little arrowed line.
Yeah, or half arrow line or some sort of line arrowy pointing to the right.
Yes, that means this is the 0 vector. And we won't deal a whole lot with the 0 vector, but there is
it comes
a 0
up every
vector.
now and then, but not super often.
Okay, so vectors can start at points other than the origin. The vector AB, for example, and that's a case where I've got a little line with an arrow over it, has an initial point A and a terminal point B. So the thing that comes first is the initial point, the thing that comes second is the terminal point.
Start and stop.
And it's pictured here below. And then usually it's best for us to put the vector in component form using the head minus tail rule, which is right here.
And basically, head minus tail rule, if I may be so bold,
go for it,
is slope. It's where you stop minus where you start for each coordinate.
It is like slope, except you're not dividing them.
Right, except we're not dividing.
Yeah, so you take the x minus the x, but you always use the second one minus the first one, and the second one minus the first one. So down here on our example, if we want to show that these two are equivalent, the vector AB, which is pictured here, and then the vector PQ, which we don't have drawn.
Right.
Well, one way to do that is to use the head minus tail rule.
That sounds like a great
component form.
Yeah.
So AB.
So what's your vector, Victor?
My name's not Victor.
Roger, over.
Okay. So we do the second one, which is -1 minus -4.
Now, minus -4, though, so be careful here. It's not just a straight up -4.
Right.
It's a minus -4 situation.
And then 6 minus 2. So that gives us, for AB, -1 plus 4.
3.
6 minus 2.
4. Bam.
Okay. And then for PQ.
Oh, there's another one?
Yeah.
How'd I miss that? I only see one on there.
Well, I didn't draw the other one because then it would be super obvious.
Oh, don't draw it. Don't draw it. Let it be a surprise.
Okay, so PQ is 2, -1, 5, 3. So -1. Nope, that's not right. That's not the second one.
5 minus 2.
5 minus 2. And then
3 minus -1.
3 minus -1.
I smell something the same.
So that's 3,
3, 4.
comma 4. And so we've shown that these are the same because we ended up with the same thing in component form. If we draw PQ the way it is, then this is where P is, and then Q is
Is that a
just ignore the infinity symbol.
Is that a figure 8?
I don't
Almost
know.
Sideways?
See how they look the same except for one was drawn as a
one of them's a
by the
straight line and one of
computer.
them's almost a straight line.
Right, but they are the same. And basically what component form does, just so you know, is it moves your initial point over here to 0, 0, so that then we would draw 3, 4. Okay, we just moved.
Looky there, they're all the same now.
Yeah,
they're all identical.
We just moved it to right there.
Yeah.
So that's to start off. Put it in component form. If it's not in component form, everything we do will need it in component form.
That's correct.